Okay, welcome to our first in the series. Uh, my name is Mr. Sufi. I'll be teaching you VCE Mathematics Unit 1 and 2 for math methods. We'll be starting with linear equations and linear variables. We'll start by giving a very short introduction, or more accurately, a short reminder of what linear equations are and what the linear polynomials are. And after that, we're going to go through some of the things that we're going to study, and we'll be solving some examples. Now, for this series, the textbook in use is Cambridge Senior Math. Although just for the start of this particular presentation, I'm using another Cambridge textbook, just because I felt that has some good material to introduce. But from next time, I will adhere to your prescribed textbook, and every now and then I might get examples from outside. Now, if you remember, if we have a linear variable, it can be, for example, x or y or z or whatever, alpha, gamma, any letter will do. We say it is linear if the power is 1. So when we say x, it's a given that it's x to the power of 1. And actually it is 1 times x to the power of 1. So we don't write it as 1 times x to the power of 1. We just write it as x. Same would be for z and y. So y to the power of 1 and z to the power of 1. We write them as y and z. Okay. Now, an equation is said to be a linear equation only if the highest power, and a matter of fact, the only existing power, is to the power of 1. So, if we have something like x plus 1 over x plus 3 y equals, then this is not a linear equation. Why? X is indeed the power of 1, y is the power of 1, and you might say, and even this x is the power of 1. But let me rewrite it in the other format. Don't forget that when you want to bring something from the denominator to numerator or vice versa, you have to change the sign. So this is the same as x plus x to the power of negative 1 plus 3. So this comes up 1 times x negative 1 is x to the power of negative 1. So we've got a power different than 1, which renders it as nonlinear equation. Now, the only exception for other power is the constant, but the constant has no variable. But 3 is the same as 3 times 1. Yep. Don't forget that any variable, for example x, to the power of 0 by definition equals 1. So y to the power of 0 is also equals 1, etc. So this can be written as 3 times x to the power of 0. But because it's not variable anymore, x to the power of 0 is just 1, rendered as 3, this is acceptable. That's the only other exception, or the only exception. Otherwise, you are only allowed to have power of 1 and a constant. Now, that you could have a multiplier to the x, that's not a problem as long as it is a fixed number, not a variable. Now, to recall the general equation, general linear equation, it's in the format y equals mx plus c. Okay, so y is the power of 1, x is the power of 1, y here is multiplied by 1, the x here is multiplied by m, and c is a constant. An example is y equals 3x plus 1. Okay, now what is happening is that number here, m, is called the gradient. Okay, so this is the gradient or the slope. Okay, this determines how steep the line is. A linear equation is a line equation when you draw it. Okay, so if we are, that's too close to the side, but this is an example. Okay, and that's another example of linear equations. Now, how fastly it rises or how slowly it rises depends on this variable here, the gradient. Okay, so the bigger this number, the faster it rises. So the most simple equation is y equal x. Okay, which means m equal 1 and c equals 0. This will be straight here, passing through the origin. Imagine this is a straight line. I'll try in the future to use a ruler. But anyway, so it goes through the right, through the center, y equals 0, x equals 0. Because, simply put, you just place it here. For x equals 0, y equals 0. It rises at the same rate. For x equals 1, y equals 1. For x equals 2, y equals 2, etc. So if you look at any corresponding point, corresponding y value is exactly the same value. While if we had something like y equals 3x, so for x equals 0, if we just look at the y equals 3x before the 3x plus 1, for x equals 0, y equals 0. For x equals 1, y equals 3. For x equals 2, y equals 6. So you see, y will be rising much faster. So this will be something like so, rising much faster than this one. Then this constant here, plus 1, shifts the whole thing by 1. So it's the same shape but shifted up by 1. If it was negative, it will be shifted down by 1.
Okay.
So now that we had a quick introduction, I will just quickly go through the various parts of linear equations that we're going to cover in the near future. Today we'll be restricted to only the first part, and I will show you some examples and solve them, and I hope that you enjoy them. Now, in addition to this, what I need you to do is, and we'll talk about it in class, I need you to create an account on Khan Academy if you don't already have one. Now, I've got in the background, I suppose I can show it to you. Okay, I've got an example here. Okay, now, Khan Academy is .org, is free, and you've got lots of things on it available, including mathematics, and you can go through the topics in your own pace, and we'll discuss it later. Okay, so let's continue. Okay, so solve linear equations in one unknown. That's the topic for today. Okay, one unknown means the equation only have x or y, but not both, or any letter, but just that letter. Okay, transpose and so forth. Well, this one, transpose just means rearrange. So you say I want, for example, u, letter u to be the subject. So you rearrange it to have u equals. Well, you might have been given something like, for example, let's say KV plus UT equals 20. All right. So they say we want you to transpose it to make the U here as a subject. So you want to end up with U equals whatever. And that would be actually 20 minus KV over T. Alright. Now also you need to learn how to construct linear equations. So you need to know this would be like worded problems. You need to solve simultaneous linear equations by the most common method, substitution and elimination. Now all of this you have done last year at year 10. It is part of the curriculum. This should be only a matter of revision. And to use linear equations to solve problems. How can we use linear equations to solve problems? Well, an example was in my introduction screen. This one here. This is an example. This could be, let's say, for example, you wanted the services of a plumbing company and you got quotes from two companies. One company, the quote that they did fit in a linear equation. So the first company in blue, shown in blue color, the equation is this. The cost is, there's initial $25. This is, for example, let's say you wanted to buy plumbing tools. So they say, okay, whatever your order is, first we'll charge you $25. So even if you wanted to buy from us something that was 5 cents, you still have to pay the $25 plus 5 cents. So there's $25 plus 4.5 times the number of items you want to buy from us. Okay. So you get their quote and then you ask another company, they tell you, okay, we charge you $50, but then you only multiply per item, you add to it quarter of the dollar times X. Alright. So if you don't do your math and you don't study it, you might think that this is paying the $50 upfront is more expensive. So you go with that one. But in reality, it's only more expensive up to where they break even here. Same cost, 100 units. So if you're buying less than 100 units, then the red one will be dearer and the blue one will be more expensive, less expensive. While once you reach, if you just want to buy exactly 100, then either one will cost you exactly the same. If you want to buy more than 100, then now the red one is the less expensive and the blue one becomes more expensive. So as you see, this helps us to solve equations. Alright, now what I'll do, I'll start doing some examples, and remember, we said that today is only we're doing this first part, which is solve linear equations in one unknown. Alright, so the whole idea is, I would like you to view this at home before coming to lesson, so the series that is, so you know that this would be the topic for the lesson next time. So before you come to class, you view it. We're going to trial and error. We'll see how this works, but this is the ultimate that I'm looking at. You look at this at home, you get the theory, you see some practices, then you come to the class already knowing that, and then in the classroom we'll concentrate on doing more exercises, and the bulk of what used to be the homework may be done in the classroom, and there's a chance for me to give you individual attention. And mathematics, there's no two ways about it. You need to invest a huge amount of time. If you don't do that, you will not get anywhere. Now, the other thing is with mathematics, you have to do lots of practice. We are preparing you for next year's BCE Year 12 exam. And there are three things to be wary of. Knowing the material is only one part. Okay? The second part is speed. That's one of the main tricks. So if you go at your own pace and you know it and you answer 100%, you might find that you still fail because you probably only did 40% of the whole questions, which means the maximum you can get is 40%. Okay? So as we go, you need to learn not only how to do it correctly, but learning all the shortcuts that enable you to solve it in the quickest and most correct manner. And the third part is actually showing your solution. Showing the solution has actually more marks than the answer itself. But to get the full answer, you need to show the solution plus the answer. If you just put the answer on its own, then you might still fail. Answer on its own, generally, like rule of thumb, might constitute, if you put all the answers 100% correctly, but not showing how you've done it, you probably will get 40. The other 60% is actually for showing how you solved it. So if you actually get all the answers wrong, but your method was correct, you probably will get 60%. But if you get even all the answers correct, but not sure how you've done it, then you might get 40%. In order to get the 100% or near to that, which should be your aim, you need not only to get the method correct, but also your calculation correct, and all the wording that needs to be done, be it shorthand, anything that the examiner will understand, and you want to put marks, and then the final answer, correct answer. And don't forget that you need to know how to do things both manually and using the calculator. So there's technology free and a technology component, and you need to learn both. Okay, so now let's start with doing some examples. Enough said. We'll start with this one, and then we'll do a few ones and we'll finish. Okay, as you see here, let's have it on its own. If we examine it, the same as all of the rest, there's only single variable. Here it's y. So if you examine it, it's 5 times open bracket y minus 3 close bracket equals 2 times 2y plus 4 close bracket. Okay, now the only variable is y.
I'm Dexter. Boy, genius. You better listen to Mr. Suvi, or you'll be like Dee. She's stupid. Stupid. She doesn't know mathematics. She's stupid.
Now, in order for us to solve this, we need to expand and simplify. But before we expand, we need to look for patterns to see if there is something we can simplify before we expand. In this case, we are multiplying by 5 and by 2. So we can't simplify it that way. And even if we took 2 as a common factor from the inside, that makes it 4, still can't simplify. And from this end, we can't simplify anyway, we can't take anything. So we can't simplify, we have to continue. But if this was like a 4 and a 2, or an 8 and a 4, then you simplify. So if it was a 4 and a 2, simplify by 2, then here you wouldn't have anything to multiply. This becomes very simple, rather than making it harder, okay, or longer. So in this case we don't, but don't forget when we multiply, and always use the brackets if there are no brackets. And this is something I'll stress on as we go. Remember, when you want to remove the brackets, you have to multiply by everything that's inside. A common fault, even sometimes year 12 shouldn't make these mistakes because they carried weakness right from primary schools and early mid-secondary, is that they multiply this only. So they say 5y minus 3, and that will be totally wrong. This is 5y minus 15, 5 times y and 5 times minus 3. Now, for things like this and others, if you know that you got weakness, you might have been sick when this was explained many years ago or whatever, then this is where khanacademy.org comes into play. Alright? So you go into Khan Academy, you find the topic and you practice and you see the tutorials and everything till you are happy with it, and you ask your teacher for help. Okay, let's continue. 2 times 2y is 4y. 2 times 4 is 8. Okay, So you get this. Now, we need to have the y's on one side and the constant on the other side. If we are to bring the 5y there, the 5 is greater than 4. Once you change from one side of the equation, the equality to the other side, you have to change sign. The 5y will become minus 5y, then the answer will be negative. And this will involve more steps. So rather than doing this, then we do this 5y, 4y, we'll bring the 4y into here, then we change the sign, it becomes minus 4y. And we take the 15, minus 15 there, and we'll change the sign so it becomes plus 15. So then what we're left with is 5y minus 4y equals 8 plus 15. So 5y minus 4y, 5 apples minus 4 apples, 1 apple. 1y, which we write as y. So y equals 8 plus 15, 23. And we finish. Okay, now let's say you did it the other way and you took the 5y there. Let's try it again. 5y minus 15 equals 4y plus 8. Okay. Now, normally if the 4 was here and the 5 was there, you've got more chance of making a mistake of taking the 5 there. But let's say for argument's sake you decided to take the 5 there, then the 5y becomes negative 5y, constant here becomes negative. So then what we're left with is minus 23 equals minus y. Why minus y? Because it's minus 5y plus 4y. So we're left with minus y. Then we need to multiply both sides by negative 1 to get y equals 23, which is the same answer. 23 equals y, it means y equals 23. It's commutative. Okay, so if I say you have the same age as your twin brother, it means your twin brother has the same age as you. Okay, so if 23 equals y, it means y equals 23. If minus 23 equals negative y, it means negative y equals negative 23. Okay, now I'll actually stop here and we'll leave the rest of these exercises to a separate session, because I think by now probably you already said too much and this is a good time for you to go and have a break, drink something, eat something, and then if you like come back and continue the rest of this video. So this will be part 1 of introduction, and then there will be part 2 of the introduction. Till then, I bid you farewell. Thank you.